HTTP connections. There are actually three flavors of HTTP connections: non-persistent HTTP, persistent HTTP, and third, persistent HTTP plus pipelining. All right, so let's start from the most basic, the oldest flavor, non-persistent HTTP. This is implemented in the pioneer versions of HTTP, let me call it that way. In that, you send one object per TCP connection. So the clients and the server sets up a TCP connection, and then you send one HTTP request, you get one web object, and then you close the connection right after that. So to download multiple objects, you need to create multiple connections one after another sequentially. Now in persistent HTTP, the main idea is, well, why do we keep opening TCP connections and closing them? Why don't we just reuse the TCP connection we have started in the first place? So in persistent HTTP, client and server establish the TCP connection, and then first web object exchange, second web object request, and the object response exchange, and so on and so forth. So one single connection to send all the objects. All right. Now, the basic persistent HTTP mode works more like that. So you have one exchange to establish TCP connection, and then it's just object 1 and object 2, and then object 3. Okay, but the thing is this: when we establish the TCP connection and sending out the first request for object 1, really, before the object 1 is being transmitted back, you see, client over here, it needs only this amount of time to send the request message, right? Client is immediately left idle right after that. So why don't we send the second object's request, the third object's request, and the fourth object's request subsequently and immediately? That way, you just need another exchange like this and, just a few more transmission time. Then we're done with everything. Unlike here, for each object, you need this much time, and the second object would wait this much time, and the third object waits even more time. Okay, so this here is the persistent HTTP plus pipelining. Nowadays, when people say persistent HTTP, the implication is that, hey, it's persistent HTTP with pipelining. And by the way, this is HTTP, the 0.9 version. And persistent HTTP without pipelining, that's the HTTP 1.0 version. And the one with the pipelining is the HTTP 1.1 version. All right. Now let's go through the animation for the very standard non-persistent HTTP protocol's behavior. Let's suppose we are looking for this object here. So the URL contains the host name, the path, and the file name. And let's see that this base file here contains 10 reference objects. So there are 10 images embedded. Step number 1, the TCP establishment. Client here initiates connection request. Server sitting at this location at port 80 will accept the connection and then send back a, sure, open it message. Second exchange is the client sending the request message. All right, so in the message, embedded is the URL. All right, so that's going to go through the socket, and URL right there in the message. Server will receive the message and sees the URL, finds the path, finds the file name, and therefore extracting content and generate the response message. And that response message is shoved again through the socket back to the client. Now, immediately after the response is sent, the server closes the TCP connection. HTTP client here receives the response, parse the HTML file and displays it. And in that process, it's discovered that there are 10 more reference objects to download. And the client then will repeat step 1 to 5 again and again and again, 10 times until all 10 objects are downloaded. And the time to do that is pretty long. Let's try to count the amount of time to complete the entire download. And we call that the time to download an entire page being the response time. Before calculating it, let's define this term. RTT, which stands for round trip time. It is the time for a small packet goes out to the other end and comes back, out and back. So it's a round trip in a sense. So client over here, server over here, to initiate a TCP connection, the connection request go, connection established, granted messages come. That's 1 round trip time, right? So 1 round trip time for initiating the TCP connection. And it's another round trip time to send HTTP request and receiving the HTTP response. So this part is 1 round trip time. But the dark, thick square here, this is the time it takes to transmit the file. Okay. So when the object is very small, this is very narrow. When the object is large, this could also be quite wide. So let me fill it up. Yeah. So the object itself could be big. The transmission time can be long. So the shadow part is the file transmission time. So the response time to download just 1 object using non-persistent HTTP is 2 round trip time. 1 here, 2 here, and then the file transmission time. Now we can try to account the response time for that page we were loading, the something.edu, the object there. So we have the base and then 10 more objects. So altogether 11 objects. If we're running the non-persistent HTTP connection, then we have 2 round trip time plus the transmission time for object number 1, the base object. For each of the 10 objects, we do more. Okay, so the transmission time might vary a little bit from object to object, but round trip times remain the same. Right, so there are 10 of these. So 22 round trip time. So 10 of these plus this one over here, the base. And yeah, the sum of the TX. Okay, and depending on which object it is for OI. All right. Now, but for persistent HTTP, the server is going to leave the connection open after sending response. So subsequent HTTP messages between the client and server will be sent over the open connection. Client can send requests, as I said, right? Persistent HTTP without further clarification, it's the persistent HTTP with pipelining. So the client here will send all the 10 requests as soon as possible. Okay. So in the end, it's just 1 round trip time plus the transmission time of all these objects. So altogether, just 2 round trip time. First is to establish the connection. Second is to download the first object. Okay. Third is to download all the rest of the 10 objects. So it should be 3 round trip time plus the transmission time required to send all these objects. So 22 versus 3. Big win over here, right? Yeah. So this is in HTTP version 1.1, the most up-to-date version.